Find the vertices, foci, asymptotes, eccentricity, and graph the hyperbola 5x squared minus 4y squared minus 10x minus 16y minus 31 equals 0. So we have a hyperbola written down in its general form. Our first job is going to be to rewrite it in one of its standard forms so we can easily tell the values of a, b, c, and where the center is, so we can do all of these things. Conveniently, I have the equation of this hyperbola rewritten over here so that we can do all the work necessary to get it into its standard form, and then we'll return back to that other board and answer all those questions. So to start, I'm going to write all of the x's together, all of the y's together, and let's go on and send that 31 to the other side. Because I think we know what we need to do here based on what we've seen with ellipses, parabolas, and way back with circles. We're going to end up completing the square twice. And to complete the square, I need to see a 1x squared and a 1y squared. So we're going to do a little light factoring. Factoring out a 5, and then a minus 4. So got to be careful with that minus. Going to change both signs there. Still an equal 31. So now on the inside of each set of parentheses, we're going to complete the square. So ignoring everything else, I see x squared minus 2x. Divide the middle term by 2, we get minus 1. Square that, and we're adding 1. So it looks like we've added 1 to this side. But I need to remember that everything on the inside of that set of parentheses happens 5 times, so I really added 5 times 1 is 5. So I better do that to the other side too. All right, on the inside of this other set of parentheses, 4 divided by 2 is 2 squared is 4. So it looks like I've added 4, but I know everything on the inside of that set of parentheses happens the opposite of 4 times, so I'm multiplying by a minus 4. So I really took away 16, so I better do that to the other side as well. Let's see, doing the factoring, I get 5 times x minus 1 all squared minus 4 times y plus 2 all squared. And over there on the other side, I see a 36 minus 16, and that's going to give me a 20. All right, well, now to get this in its standard form, I need to have a 1 over here, so let's divide everything by 20. Reducing our fractions, I end up with an x minus 1 squared over 4 minus a y plus 2 squared over 5 is equal to 1. And there's the equation of our hyperbola in its standard form. So I'm going to write that down here on the original board we were working on. And this will allow us to easily write down everything we need to know to find the vertices, foci, asymptotes, eccentricity, and to graph the hyperbola. First up, let's go on and identify where the center is. That shifted center is going to be at 1 comma minus 2. A is going to be 2, right? The square root of 4, and then B is the square root of 5, which is about 2.2. And then C, well, let's see, C squared is A squared plus B squared, so that's 9. Take the square root, and we get a 3. The vertices and foci are going to have very nice ordered pairs because A is 2 and C is 3. But my central rectangle, I'm going to have to go up and down about 2.2, that square root of 5. So let's go on and get our picture started. Let's start by plotting that center. So that's at 1 minus 2. All right, I need to be able to go left and right, 2 to find the vertices and 3 to find the foci. So I'm just going to add some tick marks here to my axes so I can do those things easily. And then I'll need to be able to go up and down 2.2-ish, that square root of 5. So let's dash in that central rectangle, and then we'll find all of the things. All right, my vertices are 2 units away from the center on that horizontal transverse axis. The endpoints of my conjugate axis are root 5 above that. So 1, 2, and then 2.2, just about there. 1, 2, and just a little bit more. All right, there's my central rectangle, and now I can dash in our asymptotes. From there, graphing the hyperbola itself is very easy. This time with a horizontal transverse axis. And my foci are 3 units away from the center. All right, let's write down the vertices and the foci, and then we'll find the equations of these asymptotes. So my vertices is very easy to find. Those are 2 units away from my center, so they're definitely at a y value of -2. And so let's see, that one's going to be over at 3, and then 3 units that way is going to put that focus over at -2. Right, we can think of adding and subtracting from that 1, but we also, I was writing down the vertices and I definitely just wrote down where that focus is. So let's definitely think about that again. Those were the foci. I need to be looking at these points here. And so that one is at a 3, but that one's over at a -1, taking that 2 away. Well, since I was trying to rush and find foci, let's go on and write those down. And again, those are on the transverse axis, so they have a y value of -2. And now I am adding and subtracting that 3, so that one's over at 4. And then there's the focus over there at -2. All right, to find my asymptotes, I need a point on each asymptote. Well, that's going to be the center, right? That's on both asymptotes. And I need to know the slope. And the slopes are going to come from our central rectangle where we go up and over, or up and over the other way. So let's just think about those slopes. M is equal, one's positive and one is negative, and I went up √5 and over 2. All right, so the slope, plus or minus √5 over 2, and then the point that I'm going to use to, on both lines there is 1 comma minus 2. So let's find the equations of each asymptote. Well, that really reduces to an algebra problem where I'm looking for the equation of a line, first with the slope of √5 over 2 passing through the point 1 comma minus 2, and then with a slope of -5 over 2 passing through the point 1 comma minus 2. And I like to use the point slope equation of a line to do this because I've been given the slope and a point, and I'm not that creative. So y minus y1 is equal to the slope times x minus that x value. Do a little distributing, take 2 away from both sides, and there's the equation of the asymptote with a positive slope. Minus √5 over 2 minus 2 is the y-intercept, and there's the slope. Not the prettiest number in the world, but let's see what that is approximately. Square root of 5 over 2 minus the square root of 5 over 2 minus 2 is about minus 3.1. And let's just see, -1, -2, -3, and looking where the asymptote crosses, even to the scale of this graph, which is assuredly not perfect, it looks like that makes sense. All right, let's find the equation of the other asymptote. So it's very much the same calculation, except for now the slope is negative. And so I distribute again. Careful with the minus, because now I have a plus √5 over 2, but I still have to take 2 away. So the y-intercept here is that positive √5 over 2, take 2 away. And so that's about, the y-intercept's about minus 0.882. And on my graph, which again, not to scale, it looks like it's going through really close to -1. So I'm going to let that be close enough since, well, I'm not perfect and I don't need my graph to be perfect. All right, I got vertices, foci, I have the asymptotes. We still need to write down the eccentricity, which is just the ratio between C and A. So here, 3 over 2 is exactly 1.5 is our eccentricity. And there we have all of the things.